Welcome to another test and teardown video. So this is another HP 5489A low pass filter. So we've got two channels and you can set the gain of 1 or 10. Input is 1 mega ohm impedance and the output is 50 ohm. So we got the two outputs here at the back and the voltage selector. Not a whole lot. I mean, HP made this unit in 1970, so this is more than 50 years old and it is super compact. Look at this, I can have it in my hand. It's not every day you see HP products made really compact. But of course this one is also a very simple product. We got some different cutoff frequencies here. So it's all the way from 1 Hertz, 3, 4, 10 and so on. So you can use this to clean up stuff that is full of noise and you want to measure the DC component, or you can use it for audio with overtones or anything bad. So the cool thing about this one is actually also this, the out function. So if you put the filter, so now you have disabled both the cutoff but also the gain. So now there's a direct connection from the input to the output. So this one can be connected in some sort of a test setup without being powered. Isn't that really nice? I think we should try and power it up and see if it works. So we got a little bit of input signal here, 100 millivolt peak, and I am in the filter out mode. So let me put this to 3 kilohertz and this one to 3 kilohertz times 1, and let's power up, and then it kind of works. There's a tiny little lamp in here. I don't know if you can see that, but it's very weak. Let's see if we can get, yep, times 10. Ooh, there is some, oops, look at that. So it has something to do with that one, right? Okay. Let's do a look. Oh, and now not times 10, it's not working. We definitely need to massage the switches here. See? Okay. The more I use them, the better they go. So there's a little bit of funny stuff here. Let's do it like this so we can see what we're doing with both of the channels. Okay, so that is 1 kilohertz in, and how about I dial the filter to 1? Yes, that is exactly what I was expecting, both to see the phase and then signal goes down. Yeah. Ooh, this is really dodgy. There's definitely also some phase. Funny stuff. It is very normal to see a phase change in a filter about a factor of 10 before the cutoff. So this is what you're seeing here. I got 1 kilohertz of input. One filter is set for 3. This is my reference. And okay, how about I just crank this all the way up to the highest possible, and then let's look at the other one, right? So you'll see phase change a lot before there is an amplitude change. Completely normal. And then we go all the way off. Yeah, it seems to be working. I will play a little bit more with this. Let's see how accurate it really is. Let's see if I can show you guys this a little bit more so it's easier to see. All right, so now the filter is almost off. I put the two curves directly on top of each other and we got a factor of 10 gain. So see, a little bit of phase change, and the other one now tracks again. So let's take another one. See, so this reveals the filter constants. They're super accurate and they track. See how well this tracks. Okay, why is this not tracking? Okay, so we got a little bit of loose connections still. All right, so tracking of the filters is really good. And also the amplitude, I don't know if you can see this, but I read 490. And this is very close to the expected, because I come with 100 millivolts input and my generator is in high set. So this is loaded with this one, then it's gained by 10, and then I got 50 ohms here. So all in all, I should see a factor of 10 and half of that, right? So this is a 1 Hertz input and I am now in 3 Hertz settings. So that means that I am actually attenuating the signal. Let's crank it up to 10 Hertz, the filter settings, but I'm still inputting 1 Hertz. I'll go down to 1 Hertz. Yeah, okay, now we should see a lot, right? Let's see how well that tracks. Ooh, yeah, now that tracks too. So that means all the filters, they track really good all the way down. That is amazing. So this was my input of 1 Hertz. How about we say 0.1 Hertz? So if I come with a really slow signal, I should get quite a lot more signal. This is what we see here. This will take a little while, so be patient. So this is 0.1 Hertz, and we also got perfect tracking in the 10 Hertz mode. That is really nice. So let's go faster, because this is driving me nuts. I wanted to know about this signal level. How much can we do? So here we go. Let's amplify a little bit more. So that was, I'm just doing this on, oops, and then we got clipping. So that will be channel 2. Is 400 millivolts, and then is it also the same? Oops. I would expect them to clip exactly. No, there are different amplifiers and they're discrete build and whatnot. So, ooh, we see some funny. Yeah, that's clear. Of course, I can just attenuate the input by adding filter. Yeah, okay. But anyway, this is a nice little unit that can amplify and filter. Very useful. Let's see what's inside, right? The internal is just as beautiful as the outside. It is really, really nice and compact. And again, try and imagine this is designed in 1970, right? So you got 1%, no, 2% capacitors as well. Yips. And look at the decoupling they wrote on. Maybe I can show you. Maybe it's, see, handwriting. That is pretty cool. So it's a 2-layer board. It looks a lot like hand layout. You can see the funny way tracks go and the funny angles, and then they go up and then oops, we need to go right and stuff. A classic hand layout. But nothing bad about that. This is also a way to do it. Tiny little transformator, voltage selection, all that is super duper nice. See, a direct and good chassis ground connection here on the mains input. I like that. Oh, there's one other funny thing. Remember I complained about the power on light is so dim? Look at this neon bulb. This is the power on, and it is black and absolutely time for replacement. And they're using a shielded cable. Look at that one. So this is the shielded cable, and it goes directly through the input B. They tried to put it as far away as they could, and then all the way to the input voltage selector, and then shielded to chassis here. So they're trying not to create a problem. Look at the power supply. So this board uses plus minus 15 volts. And what we got here is one capacitor and one power regulator. Is that one together with that one. So this is the 30 volt regulated power supply. Okay, so we got 30 volts, and see here, ground is chassis, and here we go, 2 Zener diodes, 15 volts each. They go to the 30 volt floating. Now you got plus minus 15. So they're trying to save space and complexity when it is really not needed, and only one capacitor. That is really sneaky. If you don't believe me, let's look at the schematics for this power supply, and you will see what I'm saying. I am not lying so much. Is this? Nope. This is not a socket. This is just a funny holder. It definitely looked like a socket. When I say socket, of course it is a socket. See this funny thing? When you pull out ICs like this, okay, we got 4 of them here, so it's not a big problem. You're not going to get in deep problems. But look, it's all round. So all you have to do is see there's a tap on this IC, and this goes to T in this case, not this marking. So that is a little bit weird. Why would they do that? Is that to confuse somebody? So that is a new neon bulb, and that is the old one. Actually, it's not that bad with the old one. It could have been a lot worse. I can show you some I've saved that is a lot older. I can also show you a brand new one. Funny I keep those things, huh? Ha ha! That is more better, as we say in my country when we try to make fun of it. But isn't it just nice? Now it works. It is as it's supposed to. It is that simple. Yes.